How is ocean salinity measured and monitored? Have you ever wondered how scientists keep track of the saltiness of our oceans? Understanding ocean salinity is vital, especially in the context of climate change in polar regions. Let's break down how this measurement is done. Ocean salinity is primarily measured by looking at the electrical conductivity of seawater. Salt increases the ability of water to conduct electricity, making this method effective. Traditionally, researchers collect water samples using ships equipped with instruments called salinometers or conductivity sensors. These sensors check how easily an electric current flows through a small sample of seawater. The data collected is then converted into salinity values. Modern technology has improved these methods. Oceanographic instruments now often combine conductivity, temperature, and depth sensors. These devices, known as conductivity, temperature, and depth sensors, or CTDs, allow scientists to gather accurate salinity profiles at various depths in the ocean. In addition to ship-based measurements, satellites have become essential for monitoring sea surface salinity on a global scale, including in polar regions. Satellites equipped with passive microwave radiometers detect microwave emissions from the ocean surface. These emissions change based on salinity levels. This remote sensing provides continuous data on surface salinity changes over time. However, measuring salinity from space is not without challenges. Factors like sea surface roughness, temperature, and atmospheric conditions can affect the signals. To improve accuracy, scientists must calibrate satellite data with in situ measurements, especially in complex areas like the Arctic Ocean. Here, freshwater from melting ice and river runoff can significantly influence salinity patterns. In polar regions, salinity is particularly important. It has a strong impact on ocean density and circulation. In these cold areas, temperature changes have less effect due to minimal thermal expansion. Accurate salinity measurements help scientists understand how melting ice and freshwater inputs affect ocean stratification and circulation patterns. These changes have global climate consequences. Monitoring ocean salinity in polar regions uses a mix of methods. In situ sampling from research vessels and moorings provides detailed vertical salinity profiles. Autonomous instruments, such as Argo floats, drift with ocean currents and gather data from remote areas beneath the ice. Satellite remote sensing tracks sea surface salinity variations over large areas and time periods, with improved algorithms designed for polar conditions. Together, these methods allow scientists to continuously monitor salinity changes linked to melting ice, river discharge, and shifts in ocean circulation. This information is critical for understanding the global effects of climate change in polar regions. By measuring and monitoring ocean salinity, we gain a clearer picture of how our planet is changing and what that means for the future.